We're looking at lesson 3.1. Not really teaching a whole lot new. It's a lot of review. And if it's new to you, then I'm teaching it still, though. Okay? So, the focus today is probably the path we use least to solve systems of equations. When we solve system of equations, you guys probably, your go-to methods are elimination and substitution. Okay? Unless you're forced to, graphing is not usually the way we go about it. Now, using a table, you guys might do a table more, just kind of trying to figure information out without saying empty equations. But we're looking at solving these today. So we're going to start with graphing, the one you guys use the least. So what is the solution of the system? And there's two equations given. Negative 3x plus 2y equals 8, and x plus 2y equals negative 8. Thoughts? Eli? Okay, it's currently in standard form. Do we have to use them in standard form? No. Okay, in homework it'll be mixed. Sometimes they'll be given in standard form. Other times they'll be given in, what's our better form? Even better than point slope. Slope intercept. That y equals mx plus b. Okay, so standard form is useful if you want to find intercepts. Intercepts are good if they're going to come out to be whole numbers. As I look at that first one, I'd have to do 8 divided by negative 3. That's not an intercept I want to, that's not going to be a good intercept that's going to help me. And I need accuracy for these lines. So, plan 1 here, plan A is let's take each of these equations and work with them. Negative 3x plus 2y equals 8. I would much rather have that in y equals mx plus b form to graph it. So, what's going to be my first step here? Say what? I wouldn't divide. I would try and get the y term by itself. So if we're trying to get 2y by itself, move the negative 3x by adding 3x. Okay. Negative 3x plus 3x cancels. I have 2y equals, what's 8 plus 3x? Okay, flip it around and it's 3x plus 8. How do I get y by itself? Divide by 2. If you divide the left by 2, you've got to divide the right by 2. Now, for this particular problem, since I know I'm going for y equals mx plus b, notice I didn't just put one big divide by 2, I put it under all of them. So this is going to be y equals, what's 3x divided by 2? Yeah, 3 over 2, x, plus 8 divided by 2 is 4. And what form did I get this in? This is at y equals mx plus b, isn't it? Okay. This is a necessary skill, being able to graph y equals mx plus b. I'm still teaching it, okay? So if you struggle with it, let's make sure we get it right. You want to go ahead and graph this one while we're here? Before we forget? So y equals mx plus b. Start with your b value, y-intercept of 4. What does that mean on my graph? On the y-axis, notice y-axis, we're going to go up 4. 1, 2, 3, 4. I caught some of you on the test on Friday. You'd go on the x-axis. It's always up or down. Okay? Now what? Up 3 over 2 because our phrase is rise over run. So, rise 3, run 2. My recommendation, and I am very passionate about this, or I feel very strongly, is because of what we're going to be doing, I need more than just 2 dots. I need my line to be extremely accurate here. Because if my line is not accurate, that could drastically affect my answer. So this is a situation where you will see me put as many dots as I can in to make it more accurate. So I can go 1, 2, 3, rise 3, run 2. More importantly, I can
Go down.
reverse this. Down 3, left 2. Down 3, left 2. Okay. I'm not saying I'm going to count it wrong if you don't put all those dots. 2 dots does the job, but the more accurate you are, the better. Okay, now what? Repeat the process, but for the other line, yes? So my equation is x plus 2y equals negative 8. I want to get my y term by itself, which means I need to move the x. How do you move a positive x? It's being added to something else. Subtract x. If I subtract x on the left, subtract x on the right. 2y equals, what is negative 8 minus x? Okay. Negative x minus 8 is a good switch around. Put it up, Maddie. How do I finish this off? Divide by 2. So now, y equals, okay, this is a good one to look at. What is negative x divided by 2?
Negative 1x.
Negative 1x over 2, which makes this negative 1/2
2.
x minus 8 divided by 2 is 4. Okay. Where's my first dot going?
Negative 4.
Negative 4 is my y-intercept, which means I'm going to this time go down 4. Okay. What's the slope of negative 1/2 do for me?
Go down. Over 2.
Okay, so one option to think about this is down 1 over 2.
Yeah.
Down 1, right 2. Pause and think for a moment. Is that going to give me a line with a negative slope? Think about like positive negative correlation on a scatter plot. Those are positive negative slopes. Okay. So you can go down 1, right 2, down 1, right 2. There's lots of dots you can put here, aren't there? But we can also, more importantly, do what? Up 1, left 2, because that negative is either with the numerator or with the denominator. Up 1, left 2. Up 1, oh, left 2. I like that. Up 1, left 2. Up 1, left 2. Up 1, left 2. Okay, guys. So, what do you know? The question was, what is the solution of the system? So the system of equations being the two equations we graphed, what is the solution? They point where they intersect. What is that point where they intersect? Negative 4, negative 2, is that right? So count from the origin, left 1, 2, 3, 4, down 2. My solution is negative 4, negative 2. I hate to be the bearer of bad news, but you can do all that work and not get credit for your answer because you didn't tell me the answer, right? So negative 4, negative 2, the point that on both works for both lines. Do you see why I like putting lots of dots?
Yeah.
Because I had all those dots, was there any guesswork in what my answer was when I got there? No. Now, if I had just put a couple of dots over here, a couple of dots over here, and I drew my lines, would they necessarily intersect exactly where I need them to? Maybe, maybe not. So my opinion is always the more dots, the better, or the more points, the better, because that's going to be your answer right there. Okay? Yes?
So, when it's a negative, like a negative slope,
Mm-hmm.
it's always up. It can't go like down and left, right? It has to go up and right or down and left.
If you go down and left, that's two negatives, so that's the equivalent of a positive slope. Yep. Okay, you guys got it? Okay, let's practice another graph here. Some of you I know take advantage of this graphing practice. Really focus on making sure you know how to do these. X minus 2y equals 4. So what is the first thing you're doing?
Subtract the x to the other side.
Okay. Kaden says subtract the x to the other side so we can get y by itself. So then I have negative 2y. What is 4 minus x?
Negative x.
Negative x what? Plus 4. And then what else do you have to do? Divide by negative 2. Get that divided, and then start graphing this line for me. This is an emergency? Yeah. Okay, you need to sign out over there at the door when you go out. Click down to third hour and sign out, okay? Okay, notice, first of all, my negative x divided by negative 2. What is a negative divided by a negative? I see. Okay, so a negative divided by a negative on that part is a positive. I hope you guys didn't graph too much of what I just put up here. Sorry. Okay. Negative divided by negative is a positive. So x over 2, keep in mind that's a 1x over 2, right?
Yeah.
So that's a 1/2 x. And then it's supposed to be 4 divided by negative 2, which makes this a minus 2. So, what's that mean?
It goes to negative 2.
Okay. Your starting point is at negative 2. Sorry if I goofed you guys up.
No, you're okay.
Although, if I goofed you up, that means you didn't catch the mistake either, right?
I caught it. It's just,
Okay. So, y-intercept, down 2. Slope, 1/2, which means I'm going to go up 1 over 2. I go up 1 over 2 as many times as my heart desires, and I'm also going to go down 1, left 2. And same thing with the other line. Three x plus y equals 5. How do I get y by itself? Or how did you already get y by itself, maybe? It's a positive 3x. Let's subtract 3x. So, y equals, when I say what is 5 minus 3x, let's reverse it and say negative 3x plus 5. So where do we start? The y-intercept of 5, which means I'm going up 5. What's the slope of negative 3 look like as a fraction? Negative 3 over 1. So that means there's a negative. So down 3, right 1. Down 3, right 1. Down 3, Right, 1. Technically, do I have enough dots there? Yeah. I don't have to put all the dots this time because once you find that intersection point, you're good to go. No. Okay. What do you know about the answer to this one? Okay, 2, -1.
Yeah.
Remember, ordered pairs, it's left or right first, then up or down. Okay? And there's a good example of, if I didn't have all my dots there, my line kind of got off center by dots a little bit, didn't it? And that's so easy to do. And I was even using a ruler there. So, again, the importance of all the dots. This is familiar, right?
Yeah.
You did this back in Algebra 1. I know you did because it's one of the Algebra 1 standards. So, we're going to review y equals mx plus b. We're going to look for those ordered pairs. Okay, so you're going to see a lot of graphing homework. Some of them are in the y equals mx plus b form. Some of them are not, and you're going to have to solve them. Do we need a quick reminder note of how to graph something like y equals 2? Just a little side note here. Do you remember how to graph y equals 2? I just reviewed it last week or so. Okay, the y-intercept is 2, yes?
Yeah.
And so y-intercept is at 2, and then what kind of line is this going to be? Horizontal. Okay, this is going to be a horizontal line. Or you can think of it as having a slope of 0. I'm hinting this because you're going to see a horizontal line in homework, right? I don't always get all my good hints out there, but I'm trying. You know, I try when I can remember. While I'm here, what about the line x equals 3?
Vertical.
It's vertical, and it's going to have to touch where x equals 3. So that means it goes through 3 on the x-axis and ends up being a vertical line. Friendly reminders. You would think the vertical and horizontal lines would be easier than y equals mx plus b. However, we can never remember them. So when you can't remember them, they're not easier. If you've hit that point of being able to remember them, they're pretty easy then. Yes?
Isn't that just because?
Yeah, like when it says x equals 3, x is always 3. So you could think, like, if you think ordered pairs, it's 3, 0, 3, 1, 3, 2. If there's no y in the problem, y could be anything. So, okay. Let's go down and look at this bottom.
Sure.
And as we look at this bottom problem here, it suggests using a table to solve the problem. Not saying we couldn't use equations, but that's for another day. Okay, we are specifically looking at how to use a table to solve a problem. And this is more like, if you guys are struggling to come up with equations, this is something you guys would do because you would just go through and kind of plug in values, that kind of thing. So, the growth rate of a Greenland shark is 7,500 centimeters per year, and its birth length is 37 centimeters. The growth rate of a spiny dogfish shark is 1.5 centimeters per year, and its birth length is 22 centimeters. If the growth rates remain the same, at what age would a spiny dogfish and a Greenland shark be the same length? Okay. You see what we need to answer? At what age are they going to be the same length? Now, and in all actuality, I'm going to talk about setting up equations for this, but do you have to set up equations? Not really. Okay, you could definitely do this without equations, but so let's talk about the Greenland shark. What do you know about the Greenland shark? Okay, at birth it's 37. And then what? Okay, so then it's adding 0.75 centimeters each year, right? So the first year it adds 7,500 centimeters. Then the next year it adds 7,500 centimeters, yes? Is there an expression or equation you could write to represent this? You would have had to do something like this on the test on Friday. What could we write here? Go ahead. 37 plus 0.75x. Where what does x represent? Yeah. If we do that, x is the age in years. So that is the Greenland. Okay, the Greenland is 37 plus 0.75x. Now, stick a y in front of that and we've got an equation, don't we? Which is exactly what we're leading into. What about the spiny dogfish? Can you come up with an equation or expression for that?
1, 2, plus 1.5.
Okay, 22, because its birth length is 22, plus 1.5x. Okay, and again, if you want them to be equations, then stick a y in there, right? Yes?
Because we have plus or minus x after
Yes. Yep. Okay. Officially, our direction said to use a table, yes? So officially, what I would expect to see is some kind of table set up if asked a question like this. I'm going to set up a 3-column table because in my first column is going to be the age, or in other words, the value I'm plugging in for x. Basically, I'm just organizing. My middle column is going to be my Greenland shark. And my final column is going to be my spiny dogfish. And what did we say about the Greenland? It's 37 centimeters plus 7,500 a year, right? The spiny is 22 plus 1.5 a year. Okay, guys, if we're using a table, and I know some of you guys are already finished this problem, haven't you? Okay, but if we're using a table, the idea is give me a guess. Okay, come up with a guess that we can use to start the problem. Now, do we want to start with something as small as 1? No. Okay, we want to jump up a little bit more, right?
Yeah.
You said 12. I was going to go with 10 just because 10's a nice round number.
Well, I said 12 because, like,
No.
1.75.
So go 11.
I see what you're saying there. So, okay. I'm going to go with 10 just because the 10 was easy, like mental math for me. Although I see his advantage of 12, so. So if I do 10, that's going to be what? 37 plus 0.75 times 10. What is 0.75 times 10? Multiply by 10, you move the decimal once, right? 7.5 plus 37, 44.5. Check the spiny dogfish out. 22 plus 1.5 times 10. 1.5 times 10 is 15 plus 22, 37. Okay. Are we there? No, because right now I have 44.5 and 37. I need those numbers to be the same, because at what age are they the same length? So now, should we try 11? No, because we're still a pretty good distance away, aren't we?
I say like
Okay. Jump up like 5, try 15.
yeah.
So if we try 15, it's 37 plus 0.75, 15. I lost my easy math at this one. 0.75 times 15 and then add 37.
48.
What was it?
48.
48.25? I'm going with what Ethan says there.
That better be right.
Okay. What about the other one? 22 plus 1.5 times 15.
44.5.
22.5 plus the 22 makes this 44.5. Are we there yet? No. So you're going to guess again, right?
Oh, I got it. 20. Let's do 20.
You want a guess of 20?
Yeah. I did it quick.
37 plus 0.75 times 20. Well, 0.75 times 20. Move the decimal once for the 0.
I like 20.
And then multiply by 2.
You do?
Yeah.
I thought so.
What do we get here?
52.
52.
52.
What about on the other one?
As 52 as well.
22 times 1.5 times 20 also ends up being 52.
Yeah. Like that.
So, what's the answer to my question? At what age would they be the same length?
20.
20 years. What length will they both be in 20 years? There's the 52 centimeters, right?
Yeah.
Okay. You realize what to do on the next one, right? If the growth rate continues, how long will each shark be when it is 25 years old? So basically, you're just taking 25 and plugging it in.
Yeah.
So 37 plus 0.75 times 25. What do we get?
I'll say it. 55.75.
55.75 what? Centimeters. And that is for the Greenland shark.
Green shark.
And you can also do the same thing for the spiny dogfish, right?
59.5.
22 plus 1.5 times 25. What'd you say it was, Caden?
59.5.
Okay, 59.5 centimeters for the spiny dogfish. Okay, on the back side, we're not going to do all these, but I'm going to talk about the idea behind them, okay, and just get you the idea and so you have enough knowledge. Okay, the back side talks about classifications for systems. Bless you. Being a system of equations is either classified as consistent or inconsistent. Now, if it is consistent, notice what it says. It has at least one solution, which means it could be one or more. If it has exactly one solution, then that falls into independent. What's that mean on a graph? The ones we looked at on the front side had one solution, didn't they?
Yeah.
And the graphs did what? The lines crossed once, right? They just intersected. And so the idea there is the lines cross once. Those are going to be two typical lines. Now, a dependent consistent system has infinitely many solutions. What do we mean infinitely many solutions?
Same one.
The same lines. If you're looking at equations, how are you going to know two lines are the same when you get them in y equals mx plus b form? How do we know the lines are the same? The same slope and y-intercept, yes? The slope and y-intercept are the same. And so if you want to write that, right there you could. Slope and y-intercept are the same. The other option, so if it's consistent, there is at least one solution. One or lots of solutions, because the lines lie on top of each other. The other option is inconsistent. If it's inconsistent, it has no solution. When do lines have no solution? When they're parallel, because when they're parallel, the lines will never touch, right? They can't ever cross. Now, how can we tell this looking at y equals mx plus b? Think about this. Kendra? Okay, same slopes because parallel lines have the same slopes, but their y-intercepts have to be different. So, you want to write yourself a note here. Slopes are same, y-intercepts different. Now, I don't have a lot of time for examples here, but let's pick one and look at it.
B.
How about I just go with A? Now, there is a typo here.
D.
Okay. A. 4y minus 2x equals 6 instead of plus 6, and 8y equals 4x minus 12. Okay. So, what do we need to do to be able to tell, without graphing this, if the system is independent, dependent, or inconsistent? Probably need to get them in y equals mx plus b. So let's take 4y minus 2x equals 6. First thing I'm going to do to solve for y is add the 2x. So 4y equals 2x plus 16. And then I'm going to... Oh my goodness. You catch me on this one. You didn't catch me the previous line. Okay. Valid point. I wrote 16. It's supposed to be a 6. Oh my goodness. It's a Monday, right?
Yes.
Is that a valid excuse?
Yes.
Yes.
Okay. 4y equals 2x plus 6. Is that correct? Okay. Divide by 4. And y equals, what is 2/4? 1/2 x plus, what is 6/4? Reduces to be 3/2. Okay. That's one line. Now what do we need to do?
The other one?
Do the other one. So my other one is 8y equals 4x minus 12. How do I get y by itself? Divide by 8. And here's a good reason it's important to simplify. What is 4/8? 1/2. Is that good to know?
Yeah.
Minus, what is 12/8?
Or, wait, no, I messed that up.
3/2. Okay, guys. Those are the two lines you're looking at.
Look like the same.
Same what?
Not.
Okay, same slope. So it's good to identify they're the same slope. So if it's the same slope, it's one of two options. Either the lines are parallel or they are
Not parallel.
the same exact line. They run the same direction. So they're either parallel lines or the same exact line. Which one are these? Plus 3/2, minus 3/2. Is that the same y-intercept?
No.
No.
It's gonna be-
Tricky, but these are different y-intercepts. So since they're different y-intercepts, these lines are parallel. Parallel lines will never touch. And so there is no solution. And I heard the official word back there. Inconsistent.
Yeah.
Well, your voice was sounding rather female-ish then.
I can. You just have to listen. Yeah.
Okay.
Inconsistent. See?
Okay. So inconsistent, because inconsistent is the one where there is no solution. The lines will never cross, never touch. Okay? So that's the analysis you're doing at these types of problems. Does that give you an idea of how to do those? Okay. Your homework should be in Math Excel. It'll be lesson 3-1, and there's 11 problems. There are quite a handful that are graphing, though. Okay? We got it all?